What is up, amigos? Today we're talking about the effects of the motorbike front fairing, so this front part here, on the motorbike's aerodynamics. So this comes from a couple of papers, one called Aerodynamic Performance Improvement by Streamlining the Front Fairing of a Racing Vehicle, and the other one called Effect of Windshield Configuration and Part Position on Motorcycle Performances. So they look at different aspects, and this is just an amalgamation of the research that they did. So there are two general things to consider about the front fairing. The first one is how pointy this front part is, and then obviously the rest of it, how it blends into it, but also how high this windshield should be and how curved it should be. And this second part is actually a little bit surprising, the results. But anyway, the first part is quite predictable. The more pointy this is, up to a certain extent, because you can't have it too long, and then you need it to blend quite nicely into the rest of the vehicle, but if you have it quite pointy, that is much better than having it flat. So you see a lot of, like particularly scooters, where the front is just like cut off very blunt at the front. And so the streamlines have to come in, the flow comes in, hits it, and then gets pushed straight out. So you're dumping a lot of energy into this front here, increasing the pressure on the surface, and that increases pressure drag. Alternatively, with the point here, the flow comes along, gets split fairly nicely, and there's only a very small point here where the flow is going into it and crashing and coming to a halt. So there's only a small point there with very high pressure. The rest of this region can redirect the flow much better and reduce the pressure, which then reduces the pressure drag. Then the flow goes around the motorcycle much better, and you can also direct it much better. As opposed to a front flat face there, you're really at, it's just luck really where the flow goes, and you can't really control where it's going to go along the rest of the vehicle, and that will increase the drag usually there as well. So by putting the nose pointy, the researchers found about a 5% reduction in the drag. It was about like 4.6 if you calculate it, but that also translated into much greater savings in terms of fuel when you actually go on a regular ride. So with the flat fairing, they found that with their motorbike, they got a gas consumption of 36 kilometers per liter, as opposed to this pointy bit, it went up to 48 kilometers per liter. So like a 33% increase just by making this front point pointy. Now that is the front. What about this windshield? How high up should it go? And should it be very straight up? Should it be angled? What? Well, this, as I mentioned, is quite an interesting phenomenon. So if you had a very shallow, that's usually not the best situation. So it's, what will happen is if you have the windshield quite short, the flow is going to come up and then hit the rider in the head. You can't really change the rider's noggin position or size too much because it's really kind of fixed as the person's bending down. Now, if you have the windshield too high up, it's actually going to jettison the air up, and you're going to increase the wake size. Now, if you have the windshield coming all over and actually making like this canopy for the rider to sit in or like lay in, then that is also not necessarily the best situation either, because now this canopy has to be a little bit higher to make sure that the rider can get in there. So you have a greater frontal area. So in reality, actually the best situation for the front windshield is where it comes up just enough so it's fairly in line with the rider itself. So the air comes up enough to go over the rider, but not so much that it's really giving the rider a lot more space than what the rider needs, and hence increasing the frontal area and hence increasing the drag. Now, in terms of these different windshields, the researchers found that the optimal one had the lowest drag, obviously, the coefficient, with these other ones coming in second, third, and fourth. This one, where it is a canopy, is like second, and the drag was increasing from like 1.5, the drag coefficient, to like 1.6. And then with the short one and the very large one, then the drag coefficient went up to like 1.7 or 1.8. So like a 30% increase overall just by putting this windshield too high or too low. So that is how the front fairing should look in terms of the pointiness and the height of this windshield. So that's the video. Make sure to like and click the subscribe button, and I'll see you one. Peace, amigos.